So hello everyone. I think everyone came back from the lunch break. Welcome back to this new session of presentations. I am very pleased to present to you now Paul Couturier, who is a cloud architect at Skynopy, specializing in designing and deploying cloud infrastructure for satellite communications, as well as Frédéric Laurent, so co-founder and president of Snowpack, who is also specialized in protocols and networks. So please, the floor is yours.
Thank you very much. So yeah, the idea of the presentation is to talk about like the security of space link extensions. So it's a protocol that enables a mission center to talk to the ground stations. But before that, there is like two main insights I would like to give you before the talk. So the first one is kind of humility. This topic has been already like studied and analyzed by a lot of other companies. And I would like to thank all of them, like Vision Space, ESA Cyber Team, or even all the Space Apps conference that deal and talk about this topic. I think when it comes to cybersecurity, and especially in space, you need a community, you need people to help you, because nobody has the full expertise of this. So we'll try to be super humble on these presentations, and happy to try to answer your questions. Second key insight is that we try to deal with the issue that we found on the security of the space link extension in an innovative way with the Snowpack technologies, and we'll try to deal with it, but there is like many other options, so happy to also discuss and debate about this after the presentation. So why did we create another protocol? These creations came from, in fact, an issue of like interoperability. The thing is, when we started like space sectors, every agency wanted to create its own ground segment to talk to its satellites. Basically, it was like the most sovereign way to deal with space ever. Stuff is, it's kind of expensive in terms of capex. And so in the 90s, when like mutual operations started to blow and to be born between national agencies, you needed like one control center to be able to speak to an antenna or a ground segment that was not owned by its own agency. So, for example, it would be like NES talking to a NASA ground station. This was like an ideal world where everybody could like talk to each other, communicate, or at least like partnership with each other. Unfortunately, we'll see that SLE didn't really hold on super well, due partly to the ground station as a services, but also due to the overall stuff of being able to create a new standard. For a standard to be a standard, everybody has to use it, and it was not the case for the SLE. We'll see why after. So the core aspirations behind the creation of the SLE are the 4 pillars. So the first one, these 4 pillars are actually like stated in the document of the standards. The first one is standardizations. So it's basically the fact that we talk the same language. So it's a bit, you could compare SLE to an API framework, basically, with like having people being able to talk with the same languages. It comes with like cost reductions and risk reductions, because you don't have to reinvent the wheel every time you would like to talk to ground stations. So basically, before you had like every mission control center having its own interface, and so any times you wanted to use another one, you would have to add a ground stations to your like interface software. But it also comes with risk reductions to introduce the SLE, because all the vulnerabilities, all the issue you could have would be like patched by the same community, and everybody would try to, improve the standard. And finally, scalability, it was actually well thought, because you would only have to introduce the services you need to implement the services you need, but not all the services of the SLE. It has been used by many organizations. We can see SSC, CNES, ESA, JAXA, NASA, and even the Chinese agency who actually participate in writing the protocol. So what I said that it was to talk between a mission center and the ground stations, but there were like 2 main features behind this. The first one is management services. So it's the idea of, if you have a satellite A that is talking a language A, and then a satellite B that is talking another language, between 2 contacts, you need to change and reconfigure your ground segment. And so this is true for the antenna, this is true for the baseband modem equipment, And basically, yeah, you have to be able to control and configure your devices. The second main feature, obviously, of the ground segment is to be able to retrieve your data. So if I have like an images downloaded by a ground segment and I'm a mission center, I want to be able to get back my data. And this comes with divided in two main features. The first one is when you want to do uplink, and the other one is when you want to do downlink. For those who are super interested in CCSDS, the SLE was quite well done because you could have like the type of packet you want in terms of uplink and downlink. You didn't have to either have only raw bytes to send only raw bytes, or you didn't have to have your full packets before sending it to the antenna. And it was super useful to adapt to any type of architecture in terms of ground stations. Now let's get down to why it's a kind of a bad protocol, or at least it lacks a lot of security. The idea is it has been created in 2002. So it was not designed at all with a security by design principle in mind. And this just, once you've said that, you understand everything, because they just say, in their papers, they state that, okay, we are going to fix an issue that we know of, which is like a business issue of interoperability, but we will delegate the security to upper layers, such as VPN. This is what they say in the paper. And so they only implemented the authentication feature because they needed it. You needed to know which is the client you are talking to or which is the servers you are talking to. So it was just a simple like asymmetric encryptions with like credentials on the server side, credentials on the client side, and then a maximum time allowed between generation of the credentials and the verification of the credentials. There were a super good talk of Lee Space this morning about this, about time to check, time to use, and I think it's exactly the issue you can find here. And then they didn't implement anything about confidentiality, and about integrity, they only implemented a simple CLTU counter, so a counter of packets, but it's not really like integrity checking. And for those who are familiar with CIA triad, basically, if you only have confidentiality authentications, you don't have anything. And it's what actually happened. You could like target the authentication system thanks to the confidentiality or the lack of confidentiality or the lack of integrity mechanism. And this is what have been proven in the paper of Vision Space, where they were able to exploit this lack of security in RP spoofing simulated environment. So we consider that you have mission control center and the baseband equipment, it's the same in the same LAN. And then you have an hacker who is able to access the LAN and actually like get the data and send them and be a man-in-the-middle attack and do a man-in-the-middle attack. And so they were actually able to prove like 4 exploitations. First one being like rejection of the SLE sessions by altering the packet unit. Second one would be like a replay attack because you had encrypted identifiers, but you didn't have like integrity. You could just use the replay attack because you didn't have like confidentiality. Sorry, you could use the replay attack. Data tampering was also able, and finally by using these first 3 exploitations, they were able to do a last one, which was very frightening. It's about like taking control of the entire SLE session. So basically, they are able to reconfigure your baseband modem, get back your data extra. This was done in RIP spoofing environments, but I will let Fredrik tell you how it can be done in a different environment if we're like in a real situations.
Yeah. Good afternoon. So thank you, Paul. So yeah. The POC demonstrated by Vision Space works only on local infrastructure, but it proved the point that yes, SLE was not very secure. In reality, what you would need is a global attack, and for that you would need to hack into BGP. So by doing a BGP hijacking or BGP rerouting, for those that are coming more from the space sector and less from the networks, BGP is border gateway protocol. It's one of the key protocols that is used for defining the routes across the internet. And in order to perform this kind of hijacking, you need to to control one autonomous system, which is straightforward if you are an ISP or a government. because it's your main connection. But if you don't, then you need to compromise one that can be done, but is not so easy. Also, if in the past BGP hijacking was not so hard to do, now it can be quite easily detected by operators that have set up a countermeasure for that. And therefore, you need to deploy do a BGP, STLC BGP attack. So you need to really do the attack locally and not try to advertise too much the rerouting, because then people, operators will notice it. It's in paper. Vision Space was saying that in order to secure SLE, we could implement it with VPNs. And we see two major problems with that. The first one is that if it's very easy to set up a VPN within one organization, if it's very easy to set up two VPNs between two parties, setting a VPN architectures across multiple mission control system and multiple ground system, it can be very quickly a challenge, especially in the space environment where you can have hundreds of these and hundreds of these. In practice, what you need to do is agree on standard VPN protocols, choose the authentication methods. Then, because in space usually there is a lot of data, so you will need to deploy hardware on all the ground stations. And then enroll the mission controls. And do that, maintain that across hundreds of mission control system and ground stations, so throughout their lifetime. So it's a huge challenge. There can be some alternative to that, and probably it's one of the reasons that SLE just said, do it on top of us, we're not taking care of that. But I don't know, I was not there at the time. You can have an alternative to VPNs to simplify the thing. Typically, you could use SSL protocols, but these involves setting up a public key infrastructure, which implies trusted third parties and risk of man-in-the-middle attack. And also, the other problem is that, contrary to VPNs, where all the traffic can go, all the protocols, on these, only it's a limited support of protocol will be achieved. You have, for the last 6-7 years, I know it's not very common in the space, and we'll see why, but you have the zero trust architecture, like Zscaler, Netscope, Cato networks, that have been made for the purpose of being able to connect multiple hundreds of thousands of assets throughout one overlay. So this works very well. It can, for a lot of use cases, very good, but they are all the service provider, a trusted third party. And you don't just need to trust them. They clearly do SSL stripping. It's openly known. So they will inspect all the packets. And in fact, if the packets are a bit too highly encrypted, they will be dropped and discarded. So for a lot of use cases in space, we don't think, and I guess that's why in the space sector it's not quite common to hear about these actors. It's not very acceptable for most of the space use case. Another problem of VPN is that VPN is great for against 99.9% of the threat spectrum. It's very good against script kiddies, most of cyber criminal networks. It gets a bit less good against some APTs and nation states. And unfortunately, in the space sector, a lot of threats are mostly state-sponsored. And these actors can have a lot of resources. In particular, they can deploy a deep packet inspection appliance. So you've got usually two kinds of them. The first one, a passive one. So they will just monitor hundreds of gigabits per second on the network. And they will be able to identify which mission control system talks to which ground system. Worse, there is the active appliance that will look into the metadata, that can maybe trick something in order to degrade the crypto protocol, or just drop the packet and do a DNL of service. Of course, these kind of attacks are not very stealthy. You will see it if you're not able to get to your ground station. But usually, if you put a VPN, the server will be there. And the worst part is that vulnerability VPN servers, they've got listening ports, and therefore they can be scanned. Anyone on the planet can see where is the server, what is the brand of the server, which model. And if you happen to have on the catalog some vulnerabilities, end day, 0 day, maybe backdoor, we never know, but just plain misconfiguration, we are all aware of these network administrator doing admin for logging password, but they can be exploited. Sometimes also, if you do some VPN protocol, typically IPsec can be sometimes unstable, but I won't go into this here. So that's why at Snowpack we invented 4 years ago a concept that is invisibility. Today, the most solution for securing point-to-point communication is VPNs or zero trust architecture. But because of metadata, listening port, or trusted third parties, they can be attacked at least by high-hand hackers. And that's why we introduced this invisibility concept, where we believe in order to reach that, you have to have no metadata, no listening port, and no trusted third party. So, of course, I will explain how we do it at Snowpack. We believe there's other way to do it, typically by combining different pieces, for example, Tailscale over Tor or I2P, VPN over Tor or I2P. The problem with these solutions today, at least to our knowledge, is that the quality of service is not very good, and I'm not sure that Paul would be happy with such quality of service. So we introduced something, so our VIPN technology, that is based a bit like Tor. In terms of architecture, you've got a distributed overlay, but contrary to Tor with the onion, what we're doing is we fragmented packets. Fragmentation of packets, so typically you've got an IP packet, you generate a noise. This is the first fragment, just a random byte. You XOR it with the IP packets, you get another noise. This is the other fragment. In the past, for the past 25 years since there was a research on fragmentation, it was only the payload. At Snowpack, we fragment the whole IP packets in order to erase all the metadata. And in fact, because we're doing routing circuit, we don't need to know public IP addresses from Alice and Bob. Both of them don't need to know their respective public IP address. And it works. Why? Because the route is created thanks to an auto-discovery scheme based on these snowflakes. And therefore, I will not go into details, but we have a booth, so please, I will be happy to discuss about that. But one of the main features, and this is what we believe is the key to invisibility, is that our users do not have to trust any of the nodes, any of the elements of Snowpack overlay. Why? Because regardless of the computing power, no node can know where the snowflake is coming from, where it's going to, and what it's inside, because they never see any information, not even encrypted. They never see anything about Alice, Bob, or the content. And therefore, our users do not have to trust the nodes, do not have to trust the overall infrastructure, and do not have to trust Snowpack. And now I pass it to Paul, who will describe how it implemented within Scanopy.
So if I summarize well what we've say so far is we have a protocol which is lacking a key infrastructure, key security features, which is the SLE. We have a way that has been stated to use a VPN, but we see that it's not scalable and not and have some vulnerability against a nation attack. And the last stuff I would like to talk about is how we implemented a similar to SLE-like in Scanopy in a concrete use case in AWS cloud environment. So the idea is we don't use SLE directly. The main reason we don't do that is basically because if you remember well, one of the pillars was about cost reductions and standardizations. And unfortunately, most of the baseband equipment providers did not follow the SLE. So it means that Kratos product are talking its own language with a REST API. Safran baseband equipment is talking its own language, which is binary packet. I mean, every suppliers have very good reasons to do that because it's more cost effective. They develop their own features, so they don't have all the same features. But we, as a ground station provider, are a bit annoyed because we need to control this and will not be able to use SLE. So for this, we created our own abstractions. It's another standard, but internal standard, to be able to control as accurately as possibly the baseband equipment. So the management service is not using SLE. Now we could have used SLE for the data services, but it would have meant that we would put on the customer side some frictions for them to be able to integrate in our ground stations. Most of our customers are actually not using not space experts. Very often they are more like software oriented, at least for the new space actors, and so they don't want to talk about SLE. What they want is a web standard protocol that is working well, that is supported by a large community, and so the data transport services has been replaced here by actually very standard normal protocol. And this is at least how we deal with it. I think from my knowledge, it's also what is done on the other ground stations, so ground station as a service provider. So I think it's a good way to do that, and basically it eases the life of our customers. And so, if we compare with SLE, we did a project with Snowpack about it was an ESA big project where we did, okay, we are going to, still this protocol can have some vulnerabilities. And so we are going to use Snowpack as an overlay on these data transfer services. And we did it on two interfaces, ZeroMQ and WebSocket. And so how did we do it? Basically, you've got your baseband equipment in the cloud. Then you've got your interfaces. The interface here is ZeroMQ with Datadog agent or whatever metric agent you want to use. Then you've got a proxy, which is still in private subnet, which is an EC2, and the Snowpack services is running on this. Between the two, you've got a network load balancer, which is just forwarding the packet internally because AWS is not able to provide nice solutions between EC2 and ECS to forward that packet anyway. And then you have got between these services and the Snowpack clients, you've got a secure link with a WebSocket or a ZeroMQ that enables the customer to be able to retrieve his packets from the contact of his satellites. It can be telemetry or mission data if we are talking about downlink, and it can be telecommand if we are talking about uplink. And here we did an automatations so that he doesn't see Snowpack. I mean, he knows the technologies and the services, but he doesn't care about this. He just have to implement it. It's in the SDK of Canopy in Python, and you just use it. And so this way we were able to at least try, and it's our way to do that at Canopy, try to ramp up on how we can secure a bit more the connections to the ground stations. We know, at least it was one of the main insights I get from CYSAT last year, that ground segment is a key target because it's more software oriented, but at the same time, space sector may not be super ready for this. So it has been targeted, so we try to solve a bit this issue, or at least do our best to do that. Now, the key takeaway with 2 minutes late. First, if you have to remember one thing, is SLE was created in 2002, and it has been created without the concept of secure by default. And I think it's even if SLE is going to die, and you don't have to remember SLE, what you have to remember is really that actually, if you don't think of your security in advance, you are not solving the issue. Because what they wanted to solve with this is having a standard that was basically enabling everybody to talk to everybody, but without considering the issue of everybody talking to everybody in terms of security. They are not solving this issue. So the first thing is secure by default is now normal situations, but this is a concrete use case of what is happening if you don't do it. Second thing, maybe you want to... Okay, second thing is traditional VPN is super nice for a lot of features. I mean, I would recommend use it. The only stuff is when you are, again, APT or national level attack, maybe it's not enough. Maybe it's not enough, and at least you have to think about what are your risks and what you want to protect. Third thing is about like ground station as a service. Skynopi is not different than other ground station as a service provider in terms of trying to ease customer life. I'm sure like our competitors are exactly doing the same stuff, but the idea is you don't see SLE because we wanted to like have web standard protocol that is super easy to use for everyone. And finally, you have bibliography because it's always important to quote your slide, to quote your sources. Thanks. Thank you very much.
Thank you.
Thank you for the presentation. Is there any questions from the room? I mean, it's true that it was a very clear presentation. Yeah.
Yes, thank you for the presentation. Just one question regarding the protocol you are proposing. Is there any impact on the performance in terms of latency, throughput for the end user?
So, I don't have the slide anymore. So you are talking about like the last piece between the after the basement equipment? Not from our knowledge. At least we tested in telemetry telecommand. So telemetry telecommand is about like up to 50 megabit per second. So we know it worked for this. If you are taking like other type of data flows, such as I know the data rate of Airbus Pléiades Neo satellites, it may not be enough. At least we didn't test it yet, so to check. But yeah, it could be interesting, definitely.
Are there any other questions? Well, if not, thank you very much for your presentation.
Thank you.
It was very
Have
clear.
a nice day.